Hello, you're welcome to my channel. Now in this video, we're going to continue solving past questions on logarithms, alright? So I'm going to continue with the number 3, meaning that we've already solved the number 1 and the number 2 in our previous videos. Okay, great. Now for this third question, we want to find the value of x such that this equation will be satisfied. So what I would like to do, I would like to start by doing a change of base, alright? We've learned change of base already. So if you haven't seen the video, you just go down. You're going to see a video on the change of base of logarithms, because that's what we are going to apply right here. In fact, if you're going to stay calm, I'm just going to explain it, okay? But it will be better if you go there as well. Alright, great. Now here, to change the base here, I would like to rewrite this as, so I'll first of all look at the left hand side. I'm going to write it down as the logarithm. You know, since we are having 3 as a constant multiple, that is 3 times, okay? So we can take the 3 to the power, alright? That will be x raised to the power of 3, and we put down 8 as the base, and the right hand side, I will still keep it the way it was. Today is going to be x plus 6 to base 4. Okay, so applying the change of base of logarithm, I would like to change the base to base 2 for both sides. So this is what we have. To change the base, we are going to change the base to base 2. That is the new base. So I'm going to rewrite this as a fraction, the same thing with this one as a fraction. And this is how we're going to deal with it. So this will be the logarithm of the number x to the power 3, then the base now to base 2. We are not yet done. We take it to be divided by. Now, we still put down the logarithm to the new base, base 2. So you see that the base in the numerator is something as the base in the denominator. So all we just put down is this other original base, right? We put it down here as a number. So you write logarithm to base 2, put down the number here, and put down the base here. Okay, so for the right hand side, we still do a similar thing. So this is going to be, we want to change the base to base 2, and this also to base 2. So we put this up here, x plus 6, and we put 4 down there. That's very nice, alright? Okay, great. Well, from here, I would also like to look at the denominator. Logarithm of 8 to base 2, in fact, that is just 3, alright? Because this 8 can be written as, let me solve it out here. So we're going to have the logarithm of 8, which is the same thing as 2 to power 3 and to base 2, alright? So since this is 2 to power 3, I can put this 3 in front. Logarithm of 2 to base 2 is 1, and 1 times 3 is going to be 3. So that means that the denominator right here is just 3. In fact, permit me to do this. I go ahead and clean this up, and I just put down 3 right there. You believe me now, right? In fact, this one will be 2. So go ahead and try this out. Just like I did. This right here will just be 2. So I'll clean that up, and I'll now put down the 2 like that. Very nice, right? Okay. Well, what do we do next? If I multiply 2 to that side, and multiply 3 over here, we can get something very nice, alright? Okay, so let's move on. I would like to multiply both sides by, let's say, by 6, or, okay, let me just do a cross multiplication. That is, multiply this with this one and multiply this with this one, alright, to get rid of fraction. So we're going to make use of, okay, let's continue here. So this is going to be 2 times that, 2 times the logarithm of x to the power of 3 to base 2, and then we equate it to 3 times that, so it'll be 3 times the logarithm of x plus 6 to base 2. Okay. So we've actually changed it from its fractional form. Alright, great. Well, I'm going to, I observe that the bases are the same, okay? So what I would like to do is to get rid of this constant multiple, that is to say, bring these 2 up here as usual, and the same thing to the 3. So you take note of this. This is a bracket for all. Even from the very first time. This is not an absolute value, it's a bracket. Okay, so let's just continue here at once. So this is going to be the logarithm of x to the third power to base 2. So like I said, I am going to bring this 2 to the top. So this is going to become the power of this, all right? And I equate it with this one also. So we equate it with the logarithm of x plus 6 to base 2, and we raise it to power 3, right? So that's the power. Okay, great. So since the bases are the same, we have the logarithm of this is equal to the logarithm of that. Where the bases are the same, in fact, these numbers are the same. That is to say, x raised to the power of 6, that is 2 times 3, is the same thing as, this is too much, this is x plus 6 raised to the power of 3. So we are expected to go ahead and expand this. This is too much. What do I do now? Can I solve this some way? Alright, so from here, I would like to move over to this part of the board and continue solving, alright? Okay, so we see this, that this is what we have, the logarithm of x to the power of 3 to base 2. So what I would like to do is to bring this power, okay, to become a constant multiple. That will become 3 times 2 in front, alright? So we're just going to be having 6 times the logarithm of, now when we take this 3 over to this point and multiply with 2, here x has lost its power. So it's just a single x over there, right? So this is just going to be x. And in the base, you're going to just put down 2. Alright, so we equate it with, well, I'm also going to do, okay, let's keep it like that for now. This is going to be 3 times the logarithm of x plus 6, and then to base 2 like that, alright? So you observe that if you divide both sides by 3, right? In fact, this is going to be, this is going to cancel out, and this is going to be left with 2. So 6 divided by 3 is going to give us 2 like that, alright? Okay, very nice. So what I would like to put here is going to be 2 times the logarithm of x to base 2, and I equate it with the logarithm of x plus 6, then to base 2 like that, alright? Okay, great. And you know that this 2 here, I can take it up to become the power of x, just like that. Okay, so you see that we're having the logarithm of a single base of both sides. Okay, so it's just to equate this number. So if the logarithm of this, of x squared to base 2 is something as logarithm of x plus 6 to base 2. In fact, x squared and x plus 6 are the same because they have the same basis, and we are dealing with equality sign. So that means that x squared is the same thing as x plus 6, alright? So here we've arrived at a quadratic equation that we need to solve for the values of x. So here we are having x squared minus x minus 6 equal to 0. Let's see, can we get the factors of this? Well, if we talk of negative 3 and positive 2, so I would like you to solve this using the factorization method. So what we are going to enter with is x minus 2 and then x minus 3 and then x plus 2 equal to 0. So when you multiply these two numbers, you're going to have this negative 6. And when you add them, you're going to have the coefficient of x here. So that will be x plus 2 and x minus 3. So the solutions will now be negative 2 and positive 3 instead of positive 2 and 3. Okay, so that means that x is negative 2 and then x is just 3. So these are the two values of x, right, for that particular question. From here, we used factorization method, like since we are having a quadratic equation to solve this. So you go ahead and try that. I didn't explain actually. Okay, so that's for the number 3 question. Let's go over to the 4th question.